Growing up in the 80s, I had the most wonderful privilege of watching Airwolf, a totally tubular TV series that centered on a totally awesome high-tech military helicopter and its gnarly crew as they undertook various missions involving wicked Cold War era situations. Then my buddies and I would even play the totally radical Airwolf Nintendo game in all its 8-bit glory. Anyway, since that time, I have always been fascinated with helicopters and other aircraft. Today we will examine Science Standard 5.2, Scientific Investigation and Reasoning. The student uses scientific inquiry methods during laboratory and outdoor investigations. This is quite commonly known as the scientific method. We will be using a common paper helicopter lab as our example to walk through how a student investigation should look. We will be using our text video lab template since it has been designed to guide the learner through TEK 5.2. The first item to cover is to label the lab report. We will title it Paper Helicopter Investigation. Always keep your titles simple and to the point. Next is our initial step where we identify the problem and state the question, which is what we want to investigate. So step 1 is, does the length of the rotor wing of a paper helicopter affect its flight? Step 2 is where we dig more into the topic to gain a better understanding of what we are investigating. This is our research step where we record observations of what we have previously noticed or found out about the topic. Here are some things we may have known. Rotor wings increase air friction, which means they help to slow the descent of a falling object. See, a rotor wing is a mechanical device that has 2 or more blades that revolve around a mast. And I have observed different kinds of helicopter rotors, some with 2, some with 4, some with more. Now we progress to the engaging step of the scientific method, developing a hypothesis. Remember from our previous video covering 5.2b that a hypothesis is more than an educated guess. It is best described as a possible answer to the question. This is where we want to write down in a single sentence a brief but detailed explanation of what we think will happen with a variable in our experiment. So, my hypothesis for this lab is of 3 different lengths of rotor wings on a paper helicopter, long, medium, and short. The longest wing will have the longest flight time when dropped from a height of 3 meters. Now, within our hypothesis, we have already identified our single variable, commonly referred to as our independent variable, which is the different lengths of rotor wings. Remember from our previous video detailing variables in 5.2a, the independent variable is what we are manipulating or changing in the single investigation. Our dependent variable, or the responding part of the investigation where we measure or collect the data, is the time of descent. Finally, our control variable is the item or items that must remain the same to keep the experiment fair, such as having the same drop height for each different rotor wing length and using the same type of paper for each length as well. Next we come to step 4, writing our procedures or instructions for our lab. We want to describe how to conduct our experiment listing as many details as possible. For example, we will, number 1, cut out the provided helicopter templates, then fold and attach a paper clip to the bottom. Two, drop each helicopter from 3 meters high. 3, record the time it takes to descend or fall with a stopwatch, and record the time in seconds in the data table. 4, repeat for 3 trials for each wing length. We are now ready to collect our data by testing our hypothesis in step 5 of our use of the scientific method. Here we want to fill in the table with the data we are collecting, and we need to remember to perform at least 3 trials in order to gain more accurate information. We also want to make sure to label the units we have used, which will be in seconds. In our data table, we have listed each independent variable, long, medium, and short, on the left-hand side and have recorded each trial's time. We need to average the 3 trials in the right-hand column by adding each time trial and then dividing the total by 3. This becomes our measured dependent variable, which is the specific data we will graph. Now, in step 6, we need to organize our data in a visual way by creating a graph of our information. In the field of science, we try to keep things clear and simple with our graphs. If you'll notice on the graphing template I've provided, you will see that the independent variable is most always on the bottom of the graph, which is the x-axis. You can remember this using a simple hand gesture of crossing your arms in the shape of an X and then folding them down one on top of the other, representing the bottom horizontal line of our graph. The vertical axis is the y-axis, which is where we place our dependent variable, our measurement. You can remember this by placing your arm up and spreading your thumb away from your fingers, thus making a Y shape with your vertically placed arm. Remember to always make sure you label everything on the graph. One of the ways in which we can best remember everything about graphing is to use a popular mnemonic, dry, mix, tails. Using dry mix helps you to remember which variable goes where on the graph. D stands for dependent, R is responding, and Y stands for y-axis. M stands for manipulated, I is independent, and X is x-axis. As for tails, this is our rubric for making a clear and well understood graph. T stands for title, which needs to be appropriate and descriptive. A is axes, which needs to have the correct variable placed on each one. I is interval, which should be evenly spread out for the graph to keep it clean and organized looking. L is labels, where both axes and the unit used are clearly recorded. Finally, S stands for scale, which should be appropriate to the data. This is important visually since it is here that someone can make the data look differently than what it is really saying. For example, if I were plotting 2 data points of recorded temperature between 2 days, one day being 91.3 degrees Fahrenheit and the other 92.4 degrees Fahrenheit, and I plotted them in a graph whose scale was 91 to 93, then it appears to be a massive spike in temperature. However, if I take the same data and plot them on a graph whose scale is 0 to 100, then it appears that there was very little change in the temperature between the 2 days. When graphing, it is important to consider how best to accurately portray your data in a clear way. Thus, by using dry mix tails, you can accomplish a well-produced graph every time. Let's now plot our helicopter data. I have clearly labeled every part of my graph to make it clear to the reader what is being portrayed. My scale is between 1 and 2.3. However, I labeled them as 1.00 and 2.30 due to my data having 3 significant digits such as 2.19. When we plot the data and create a bar graph to represent the data, we begin to see the difference between each independent variable of wing length. I then placed my exact data points on top of each graph and gave each bar a different color in order to make it more clear to the reader what the data is showing. We can evidently see the long and medium length rotor wings are fairly close in flight time, but the longest rotor wing clearly has the longest flight time, or time of descent, thus giving support to our hypothesis. Our last section, step 7, is our conclusion. This is where we try to effectively communicate to the reader what we have done, the results we've received, and our analysis of the hypothesis we've developed. In the Text Video Lab template, I provide 6 prompts to help guide the investigator in writing a clear and focused analysis. Make sure to write in complete sentences and write as if the reader has no clue about anything you have just done in your experiment. Assume that they need you to explain everything for them. So for our paper helicopter investigation, our conclusion is as follows. 1. The question was, does the length of the rotor wing of a paper helicopter affect its flight time? 2. My hypothesis is that of 3 different lengths of rotor wings on a paper helicopter, long, medium, and short, the longest wing will have the longest flight time when dropped from the height of 3 meters high. The average flight time of 3 trials of each rotor wing device shows that the longest wing stayed in the air for 2.19 seconds, the medium length 2.08 seconds, and in a short length wing for 1.56 seconds. Based on the data, my hypothesis is supported. I can infer that providing more surface area on a rotor wing, this will increase its amount of air friction, thus allowing it to stay in the air longer. I did my best to maintain good constants for my experiment, such as using the same type of paper and dropping from the same height. However, I noticed that on each rotor wing device from the provided template that the body of the paper helicopter also changed in size. So, the body of the helicopter should have stayed the same size with only the wing length changing. The one variable I changed for my helicopter lab was the rotor wing length, the independent variable. I measured the flight time of each rotor wing device and averaged the 3 trials. After analyzing my data, the evidence supported my hypothesis that the longest rotor wing length of a paper helicopter would provide the most flight time due to the increased surface area of the wing. We have now completed our 7 steps of the scientific method. However, you may want to do a short follow-up to your lab by looking more critically at what happened or how you did things during your investigation. You may also want to consider other factors or variables that influence your experiment, or consider what else might be an influence in your investigation. For example, in our paper helicopter investigation, I state as a follow-up, I wonder if the ceiling fan or air conditioner affected the flight of the paper copters. I also wonder if I could change my variable to be various angles that the rotor wings have, or bending the tips of the wings up or down. You may complete the second prompt of the lab follow-up document if time allows. I hope the sample lab provided you with a greater understanding of how to perform an investigation using the steps of the scientific method as listed in the Texas Standard 5.2. Remember, our lab template is free to download and use for any type of experimental investigation. Now go forth and investigate the world around you.